Hello and welcome to Train Signal. You're watching video number 5, Virtual Disks. This is part of Fast Track CBT Video Lab, Microsoft Virtualization, Virtual PC, and Server. This is our table of contents for this video. We have a lot to learn about virtual disks. First, we'll talk about disk file types and common virtual disk questions. Then we'll learn about removable media and disk images, dynamically expanding virtual disk, fixed virtual disk, linked virtual disk, undo disk and differencing disk, how to convert virtual disk, compact, merge, and chain virtual disk. With that, let's get started by moving on to our scenario. In our scenario with the Blue Crab Food Company, you've tested your network configuration and you need to decide what type of virtual disk options you'll use in production. To do this, you'll configure each of these different types of virtual disks on your test server in your test network. Now let's talk about different disk file types and some common virtual disk questions. Now first off, when it comes to virtual disk, to a virtual server, a virtual disk is a physical disk attached to a disk controller on the virtual server. Let me restate that because that's an important point. So to the virtual server, a virtual disk is just a physical disk that's attached to a disk controller on the virtual server. So inside your virtual server, you have a virtual disk controller and you have a virtual disk. But to the host machine, that virtual disk is just a file that's really on the host machine's physical disk. So this virtual disk that you could have inside your virtual server could be one of two types. It could be either an IDE or a SCSI disk, and I'll be explaining the difference in just a second. Now, the type of virtual disk you'll have will depend on the type of disk controller that it's attached to. So if you have an IDE disk controller, you'll have an IDE disk. If you have a SCSI disk controller, you'll have a SCSI disk. But remember, no matter the type of virtual disk, these virtual disks are just files inside your computer's physical hard drive. So even though they look like real disks to the virtual server, it's really just a file that's located on your computer. Now, just like a regular disk drive, a virtual disk can become fragmented and need defragmenting. You may also want to format it or partition it. So to the virtual server, to that virtual guest operating system, these virtual disks are just like any other disk drive that you can format. You can do scan disk, you can do check disk, you can partition it, you can do all these different things you would do with a physical disk, you can do with the virtual disk inside your virtual server. Now, virtual disk drives have a file extension of .vhd on the physical host disk drive. Now, just like your computer's host disk drives, when these disks are first created, they must be formatted and partitioned. The file allocation table for a virtual disk is stored on the virtual disk, so it's really no different from a physical disk drive. All right, now let's talk about some frequently asked questions about virtual disks. First off, what are the two types of virtual disks and the good and the bad of each? Well, there's two types of virtual disks. One is IDE, the other is SCSI. Now, the default type of virtual hard drive is IDE. An IDE disk, if you use IDE, you can have up to four IDE disks on a single virtual machine. So you have a virtual machine, you can have up to 4 IDE disk drives on that one virtual machine. That's it, no more. Now with SCSI, you can have up to 28 SCSI disks on a single virtual machine. But keep in mind you would have to change from the default of IDE to SCSI to have the ability to have more than just 4 disks on a virtual machine. Now another limitation of IDE is size limitations. So the question here is, how large can my virtual disk be? Well, with IDE, you can have a single disk up to 127 gigabytes. Now with SCSI, on the other hand, you can have a single disk up to 2 terabytes. So with SCSI, the limitation would be 2 terabytes per virtual disk, and you could have up to 28 of those 2 terabyte disks. With IDE, on the other hand, you can have up to 4 disks of 127 gigabytes each. So IDE certainly has limitations, but many people never really go beyond, even 10 or 20 gigabytes per virtual disk or per even virtual server. So many people don't realize the need for SCSI, but it is there, and you need to be aware of the limitations between IDE versus SCSI. So now let's scroll down here and let's talk about how can I increase the size of my virtual disk. Well, if you have a dynamic virtual disk, which I'm going to talk about here in just a minute over here in this slide, if you have a dynamically expanding virtual disk, the increase in the size is automatic. On the other hand, if you have a fixed virtual disk, it's very difficult or impossible to expand your fixed virtual disk. However, you can easily add a second virtual disk. And I'm going to talk about the difference between fixed and dynamic over here in a couple upcoming slides. Now, another question is, where is my virtual disk linked to my virtual machine? The answer to that is in your VMC file, your virtual machine configuration file. You'll find that over in the shared virtual machine folder, and there's a subfolder for the particular virtual machine you're talking about. One more question is, can I copy or move virtual disk while in use? And the simple short answer is no, don't do it. Don't try to copy or move virtual disk while in use. How do I move a virtual disk? The short answer here is shut down the virtual machine, move the disk, then change the path inside virtual server. So let's take a second and let me show you how you would move a virtual disk. Many times people will run out of space on one physical disk on their host computer. Maybe they have a second disk or a disk array. They'll want to move the virtual disk from one or more of their virtual servers over to another secondary disk or another disk array. So this isn't hard to do, but you just have to understand this last part here, which is change the path inside Microsoft Virtual Server. So if I go over here, let's open Virtual Server. Okay, now let's minimize everything. Let's go to My Computer, and let's go look at these virtual disks. So I'm going to go to the C drive, inside Documents and Settings, then to All Users, then there's Shared Documents, and here we have Shared Virtual Machines. This is where my virtual disks are stored. So if I go inside Shared Virtual Machines, you see a folder for each of my different virtual servers. If I go inside this virtual server, you see here the virtual hard drive. This is what I need. This is the virtual hard drive for this virtual machine. Now if I go over here to the client status, you see this virtual machine is running. To move it, I would need to shut it off, shut down the guest OS preferably, or turn it off. Then go into the configuration for this virtual machine. I'm going to scroll down to the hard disk here, click on this, and it says you can't make any changes because the virtual machine is running or saved. But basically, I would, after it was shut down, I could make changes. So I would change this path right here to the new directory, the new location for my virtual machine. So it might be f:" virtual machine hard drives / blue crab food winserver2 / blue crab food -winserver2.vhd. So I would change that path. I would move the file just here inside my my Windows Explorer. I would copy this and or cut this and then paste it over on that F drive in that particular folder. I would apply the changes here over my virtual machine administrative web interface, then restart the virtual machine, and I would have moved my disk drive. So it's that easy to move an entire disk drive for a server or a Windows XP workstation, let's say, from one disk drive on your physical host computer to another disk drive on your physical host computer. It's that easy. So with that, let me close this out and let's go back to our slides. All right, so we talked about moving a virtual disk. We already found out that a .vhd file is a virtual hard drive. A common question is, what is a disk image? A disk image is typically an ISO file, a .iso file, used as removable media. And we talked about this a little bit earlier in the video series, how you could take many of your common CDs and DVDs that you would use on a virtual machine to install the operating system or to install common applications, create disk images of those, and then use them as removable media. And I'll be talking about that here in the next slide. Next thing I want to talk about is save state. What is save state? Well, save state is an option to pause a virtual machine. Now, this is similar to hibernate on a laptop. So on a laptop, you go into hibernation mode, and it saves everything that's running, everything that's in RAM, to a disk drive file. And that way, when you come back, you don't have to reload Windows. Everything you were running is loaded from the hard drive back up into RAM, and then you're right back where you were. Well, save state is just the same thing, but inside Microsoft Virtual Server. So let me show you how the save state is accessed. If I go and I open up my Virtual Server Administrative Console, you see here, here's this Blue Crab Food Win Server 2. If I go over the status of it right here, I can edit the configuration. I can do remote control. I can pause it, or I can save the state. Pausing it just basically freezes it and doesn't allow it to process any further. Saving the state actually is similar to hibernate, where it shuts it down, it powers it off, but it also saves everything that was running in RAM so that when you power it back on, it's going to bring it back exactly where it was before. Now, this is a great feature. It's very useful, but you have to be careful what you use it for. Make sure you don't do this on domain controllers, because domain controllers are very sensitive to time. And if they know they've been sort of paused for a long period of time, they think they're still, back when they were paused, but the time has moved forward, they'll get confused and the security and authentication of Kerberos won't work anymore. But this is a very useful feature, save state, for certain types of virtual servers. In fact, most virtual servers. It will work great. Now the next question is, what is a .vsv file? Well, speaking of save state, a VSV file is a virtual save state file. It contains the state of the virtual machine when it was paused. Well, I should say the state was saved, not paused. Now, don't use save state on domain controllers. We talked about that. Let's go over here and let's do save state on this computer. And notice up here it says the virtual machine Blue Crab Food Win Server 2 is being saved. And it's updating that status bar there. It says saving state right here. And I'm going to be impatient. I'm just going to click refresh. Okay, and it says it's saved. So now let's go and look at the virtual hard drive directory for that virtual server. And right here you see a .vsv file. So that's the virtual save state file. You notice it's 77 megabytes, and this is the contents of RAM when that virtual machine was shut down. So if I go back here and I move my mouse over this and I say restore from save state, notice I can also discard the save state if I wanted to, but I want to restore from save state. Notice it says the virtual machine Blue Crab Food Win Server 2 is being restored. It says restoring, and now it's running just almost instantaneously when compared to having to reboot the whole virtual machine. So it got us up back much, much faster. If I go back here and I do a refresh, that save state file is still there as long as the server is running. If I were to shut down the server, that VSV file would go away. So that's what save state is. And let's go back to our slides. And the last question here is, what is a VUD file? A VUD file is a virtual undo disk file. And I'm going to be talking about undo disk, but just so you know, if you saw a .vud file, that's what it is, a virtual undo disk. So now let's move on to our next slide. All right, now let's briefly talk about removable media in disk images. Now you can access media on the guest operating system either by mounting physical CD/DVD disc or by mounting virtual ISO files. If you'll remember, we talked about this back in video number 3. I just want to touch on it briefly as a review so that you're well aware of how ISO files and disk images work. Now, to use physical media from the host operating system, you can edit your virtual machine's CD/DVD drive properties and select the host CD/DVD drive that you want to mount on the guest OS. To use virtual media from the host, you edit the drive properties and you select the ISO file from the host. Now, the benefit to using ISO files is that they're much more convenient and faster than real physical CD/DVD drives. And you can have plenty of them available so that anytime you need them, you can quickly just go find the ISO file that you need and mount it without having to search through CDs or DVDs, some of which might have been damaged or scratched in storage. So let's just go take a look at this before we move on. To configure virtual CD/DVD drives, you go and you configure the server. So I'm going to edit the configuration here on the server. If I scroll down, here it says CD/DVD. It says one virtual CD/DVD drive is installed, and it's an ISO image pointing to Office 2003 Pro Enterprise. Notice the .iso. So I can easily go here and I can easily add another known image file. Here's the VM additions. Notice that it tells me that CD/DVD drives cannot be added, moved, or removed because the virtual machine is running, but you can still capture media. So I'm not going to say OK on that, but the important thing is that you know how to add virtual CD/DVD drives. And as well, you can add hardware or physical CD/DVD drives. So you have the physical and you have the virtual, also known as an image file. All right, so let's go back. We talked about removable media and disk images. Now let's learn about virtual disks. So now let's talk about dynamically expanding virtual disk. Now on a virtual machine, when you aren't concerned about the performance as much as convenience, dynamically expanding virtual disks are your best choice. And when I say you're not concerned about performance, well, certainly everyone's concerned about performance to some degree. But it's just a question of which one do you value more. I mean, using dynamically expanding virtual disk, you're not going to hamper your performance significantly on a regular test machine. Now, if you have a production virtual server, you need to look closer at the performance and take that into account more. And you might choose not to use dynamically expanding disk on a production machine that's getting hit pretty hard with a lot of disk changes. Now, dynamically expanding virtual disks start small on your host physical disk, but appear to be whatever size you configured on your virtual machine. Now, over time, as the virtual disk data grows, it also grows on the host machine. So this way, you could create a 125 gigabyte virtual disk on the virtual machine and install Windows XP. However, on the host virtual disk, it might appear that the new Windows XP computer's virtual disk is only 5 gigabytes. This is the VHD file that I'm talking about that's only 5 gigabytes. And that's because you just installed Windows XP, and Windows XP certainly doesn't take up 125 gigabytes. So the more files and changes that are put on that virtual hard drive, the larger the virtual hard drive grows. But it starts out very, very small and just grows as files and data are added. Now it would grow up to a maximum of 125 gigabytes. It can't grow past the maximum size that you set for that dynamically expanding virtual disk. Now, the advantage to using dynamically expanding virtual disks is that because of how dynamically expanding virtual disks work, the host disks are not taken up by unnecessarily large disk files. So what that means is you can create a 125 gigabyte dynamically expanding virtual disk, install Windows XP, and only use, say, maybe 5 gigabytes of your host physical disk. Now, on the other hand, if you use the alternative, which is a fixed virtual disk, you would have actually had to allocate 125 gigabytes out of your host's physical disk, even though you only installed 5 gigabytes worth of Windows XP operating system files. So there's a big benefit when it comes to conservation of disk space when you use dynamically expanding virtual disks. However, dynamically expanding virtual disks are not without their disadvantages. So here are 3 disadvantages. One is you get poorer performance than fixed disk over time because of defragmentation. Now what this means is Say I install Windows and that uses 5 gigabytes of the virtual disk. And say I don't do anything else and I use my host computer, I use some other virtual servers, I create more files on my host physical disk. Well, then the next time I go to install, say, Microsoft Office a month later, I install that on my same virtual disk that had 5 gigabytes in use. But instead of putting the new applications and the new data contiguous with the other 5 gigabytes of disk space, it puts it somewhere else on my host's physical disk. And because of this, it's immediately defragmented, and this reduces your performance. So because fixed disk would have immediately allocated 125 gigabytes of disk space, it would have done it all in one chunk so that it could never be defragmented or, never be fragmented on the host computer. So one disadvantage of dynamically expanding virtual disk is that they get poorer performance than fixed disk over time because of fragmentation. I'm sorry, this should be fragmentation right here. All right. Second one is you cannot easily shrink a dynamically expanding virtual disk. So once, say you put 10 gigabytes of data on it and it expands to 10 gigabytes, and later you take the 10 gigabytes of data off and you want to shrink it back down, there's not an easy way to do this. It can be done. In fact, there's a utility called pre-compacting that will assist you in doing this, but it's not like you have a 10 gigabyte disk and you delete 5 gigabytes of files off of it and it's immediately going to shrink down to 5 gigabytes. It just doesn't work that way. You have to go through a process that's not very easy to get it to shrink down back to 5 gigabytes. Now it can be done, just not very easily. Then the third disadvantage is that you could easily run out of disk space on the host physical computer. So as I say I have two virtual machines and I create 200 gig dynamically expanding virtual disk. But I just install Windows XP in both of them, so they only use 5 gigabytes of disk space on the host. We'll say the host really only has an 80 gig hard drive. Well, those virtual machines could easily expand up to 200 gigabytes, which at the point of 80 gigabytes would max out the host, and then virtual machines would start having some serious problems when they start running out of disk space with dynamically expanding virtual disk. Even the host computer would start having some serious problems because it would be out of disk space. So it's something you have to really monitor if you create virtual hard drives that are dynamically expanding and could expand past the point of the physical hard drive space on the host. So with that, let's give it a try. Let's create some dynamically expanding virtual disk on our Blue Crab Food test network over here. So first I'm going to go in and I'm going to shut down this guest operating system. That's what I need to do before I create any new disk drives. The next thing I'm going to do is go over here to create virtual disk. And you see I get these choices: dynamically expanding virtual hard disk, fixed virtual size hard drive, differencing virtual hard drive, linked, or a virtual floppy drive. So the only options here are to create one of these or to inspect one of these over here. So those are the only options really you're given inside the virtual disk section here. So if I say create and I say I create a dynamically expanding virtual hard disk, first off it asks me the location. I'm just going to create it in sort of the root directory for all the virtual machines, which is shared virtual machines. And then here I'm going to type the file name. Let's say I call this test1.vhd. Then here it asks for the size in gigabytes. Well, I'm just going to create it as 100 megabytes for our test. All right. Now it tells me here in the log that the virtual hard disk test1.vhd was successfully created. So let's go over here and let's check it out. If I go into my computer, go to the C drive, go to Documents and Settings, All Users, I go into Shared Documents, then into Shared Virtual Machines. You see here, here's the virtual hard drive I created. Now what do you immediately notice? I created a 100 megabyte virtual hard drive. Well then why is the size over here only 3 kilobytes? Well, hey, that's the dynamically expanding virtual hard drive. That's the beauty of it. I only created a 3 kilobyte file on my physical hard drive, when in reality, my operating system is going to think that I have a 100 megabyte virtual hard drive. Now, that's not very big, but I created it with those sizes just to show you the point. Even if I created a 100 gigabyte virtual hard drive, I would still have over here only a 3 kilobyte virtual hard drive file. So that's the beauty of how these dynamically expanding virtual hard drives work. So now let's go and create something on that virtual hard drive so you can see that it really does expand. So to add that virtual hard drive, now that it's a virtual hard drive inside a virtual server, I need to go to the server over here. Well, I thought I had shut down the computer, but I really need to turn it off. Okay, we got that machine turned off. Now I'm going to go and configure the virtual machine, WinServer 2. If I scroll down here to hard drives, notice it just has one hard drive, and currently it's a virtual hard drive, maximum size 6 gigabytes, currently expanded to 1.4. That right there tells you that it's a dynamically expanding virtual hard drive, right? Because it's currently expanded to 1.4 gigs, its maximum size is 6 gigs. If I go in here and I say add hard drives, and the next thing I need to do is to add my new virtual hard drive. So I click add disk right here. I scroll down and scroll over. You can see here it's adding it on the secondary channel. Notice these 4 different channels. These are all IDE disk. So it says the primary channel's in use. That's my primary hard drive right here, the Blue Crab Food WinServer 2 virtual hard drive. The secondary channel is already in use, and that's for the CD drive. So you have to be careful here. You don't really have 4 virtual disk drives, hard drives. You have 4 IDE drives that are shared between hard drives and CD drives. So I'm going to use the first secondary channel, which is 0. Then if I do the drop down here on the known hard drives, um, there are no known hard drives that we can add. So what I need to do is go get the fully qualified path to the file. If I go back over here, if I go to the top here, I can copy this path and I can paste it in here. And then I can put a slash. Then I can get the name here of my virtual hard drive, copy that, go over here and paste it in there. I could have also copied this path here and then typed in the virtual hard drive um, in the right folder. So I'm going to say OK there. Let's scroll down. Let's see if we added our new virtual hard drive. Sure enough, we did 100 megabytes. Notice here how my new hard drive has been added. It's on the secondary channel. Whoops, that's the automatic refresh. Okay, let's go back down here. Here's my new hard drive. Here's the name, test1.vhd. Maximum size is 100 megabytes. That's what we defined as a dynamically expanding virtual disk. And it's currently expanded to only 3 kilobytes. Hey, that's great. So let's start up this virtual machine and let's put some data on this virtual hard drive. So to do that, I'm going to go up here and turn on my virtual machine. I'm going to choose to do remote control on it. It'll take just a second to boot up. As soon as it's booted, we'll log in and we'll use our new virtual hard drive. Okay, I hold down the right Alt and I press delete. And there's a little bit of delay there. Come on, give me a login prompt. There we go. I had an unplanned shutdown. All right. Close out some of these automatic pop-ups. I'm going to turn off the clock here just so I don't have to look at it. And let's go into Start, and let's go to My Computer. Now notice here that I don't have this new virtual hard drive. It just hasn't been magically added for me. And I have my CD drive still, my DVD drive. So I need to add this new hard drive just as if I installed it physically in this computer. So to do this, I'm going to go and I'm going to start under Administrative Tools, My Computer Management application. This is going to help me run Disk Manager, Disk Management right here, so that I can configure this new hard drive. It says, welcome to the Initialize and Convert Disk Wizard. This helps me convert empty basic disk to dynamic disk. I'm going to scroll through this. It says I have a new disk to initialize. Do I want to convert it? I'm just going to say cancel for now. So I have this C drive. So that's my main system disk, is the C drive. But what I have new that's down here is disk 1. This is my new, notice it's 94 megabytes, it's almost 100 megabytes, and it says it's unallocated. So to bring it in, I'm going to right click on it. I'm going to do Properties. It says it's a virtual hard drive, it's working properly. I go to Policies, there's Write Cache, some volume information, and a driver. So what do I have to do to use this disk? Right here. You don't want to just right click on this. It doesn't give you the option you need. You need to right click over here under Initialize Disk. And really, if we had have gone through with the initialization process, it would have got us there anyway. So I'm just going to say OK. Now it says it's a basic disk and it's online and it's unallocated. So I need to right click on it and say New Partition. This helps me create a new partition. I'm going to just make this an primary partition, 99 megabytes. I'm going to assign it drive letter. I like M today. We'll call it new 100 megabyte disk. And I'll perform a quick format automatically. We'll format with NTFS, say next and finish. It says it's formatting and it's healthy. And there we go. We have our new 100 megabyte disk. If I close this out and I go into Start, My Computer, here's our new disk right here, drive M. So let's put some files on drive M. If I go to the C drive, let's see, let's find some files that'll take up a little bit of space. I'm going to change the folder options here. Oops, so I can view, let's see, show hidden files and folders. I don't want to hide protected operating system files. I don't want to do that. I want to see all the files here. So here I have a 589 megabyte file. That's not going to fit on there. Let's go into Windows. Let's find something we can put over there. It's not too big, but not too small. Maybe inside System 32. Let's sort this by size. And here's a 12 megabyte file. Let's copy this. Let's put it over on drive M. And I'm going to just paste in there. There we go. We just copied in our 12 megabyte file. Now let's go over to our Windows Explorer. And if I refresh this, notice now we have a 24 megabyte virtual hard drive. So that virtual hard drive that was 100 megabytes but dynamically expanding was really only 3 kilobytes. Now it's expanded up to 24 kilobytes just by me, or I'm sorry, 24 megabytes just by me formatting it and initializing it and putting a 12 megabyte file on it. So you see how the file size here is changing and how easy it was to add this dynamic disk that's 100 megabytes. It could have been 100 gigabytes for all that matters. You know, it started off very small and it continues to grow. So this is how dynamic virtual disks work. So with that, let's go back to our slides. All right, and we learned about dynamically expanding virtual hard drives. Now let's learn about fixed virtual hard drives. Now let's talk about fixed virtual disk. So a fixed virtual disk is fixed in size on the physical host computer's hard drive. From the name that seems pretty obvious, but let's learn a little bit more. So when you create a fixed virtual disk, the disk from the physical computer is immediately allocated. So what that means to you is if you create a 125 gigabyte virtual disk for your virtual machine, you will have automatically allocated 125 gigabytes of real hard drive space off of your host machine's physical disk drive. So you have to make sure you have at least that much space and hopefully some more so that your host computer can continue to, do whatever you do on it and have a little bit of disk space left. Now, the reason to use a fixed virtual disk is when you know how large your operating system, applications, and data will be. If you don't know how large they'll be, then I recommend a dynamically expanding virtual disk. Fixed virtual disks have a benefit in that they get better performance because that disk space is immediately allocated, so there's never going to be any defragmentation of that file on the host. It'll be allocated once and only once. And as data grows on the fixed virtual disk, the file on the host computer's hard drive isn't going to change in size, and it's not going to get defragmented. Now, this is especially useful for applications that demand a lot of performance on the disk drives, especially when it has to do with writing to the virtual disk. So the benefits to virtual disk are that they get better performance than dynamically expanding virtual disk, and there's no unknowns as the data grows. So in other words, once you allocate that hard drive space, you know where it goes, you know what server it belongs to, unlike dynamically expanding disk where those dynamically expanding virtual disks, they might grow and grow and grow over time, and eventually you'd run out of space on your host computer's disk drive. That's not the case with fixed virtual disk. Now, the detriments to using fixed virtual disk is that it could be an inefficient use of disk space on the host. So if you know that the host is only going to use 20 gigabytes forever, and you allocate 20 gigabytes, well, great. You're not having any inefficiencies in disk space allocation. However, if you're not really sure how much disk space your host is going to, or your guest operating system is going to use, and you allocate 20 gigabytes on the host, but it really only uses 5, then you just wasted 15 gigabytes for as long as that host is there, potentially forever. So with that, let's go learn about fixed virtual disk. We're going to go create one ourselves and just see how it works. So for me to create my new fixed virtual disk, I'm going to have to first shut down my host computer. I'm sorry, my guest computer. I'm going to go back to the master status to do that. And since nothing's happening on that guest computer, it's safe just to turn it off. That'll save us some time. Obviously, that's not the best thing you should do for a production server. So now let's go over here to create virtual disk, and I'm going to create a fixed size virtual hard disk. So to do this, it asks for a location. Again, I'm going to create it in sort of the root directory for all the virtual machines. I'm going to go over here and call our virtual disk text or testfix.vhd, and let's make it a 100 megabyte test fixed virtual disk. I'm going to click create, and we created our virtual disk. Well, we're in the process of creating it. You can see the little progress bar right here. I'm going to click refresh, and it was successfully created. You can see that in the recent event log right here. So now let's set up our Blue Crab Food WinServer 2 to actually use this virtual disk. So I'm going to edit the configuration. I'm going to scroll down here, and you can see right now we have 2 hard drives, the original hard drive and the secondary channel 0 hard drive here, which is our dynamic test disk. And you can tell it's dynamic easily by right here where it says maximum size is 100 megabytes, currently expanded to 24 megabytes. So it's not expanded to take up the whole space. If this was a fixed virtual disk, it would be expanded all the time to take up the whole space. Now, this could be a little misleading if you did happen to have a dynamic disk that was completely filled up at its maximum, but that usually doesn't happen. So let's go into hard disk, and I'm going to scroll down here. I'm going to click Add Disk. So we created the disk, and now we want to add it to this virtual server. So if I scroll over here, I only have one channel left. It's this secondary channel 1. I'm going to choose that. I don't have any known virtual disk because it's looking in the path for this virtual server. And I put it in the root path here for all the virtual servers. So I'm going to copy this path here and go back down. I'm going to paste it in here. And I'm going to type in the correct name of our virtual disk right there, test-fixed.vhd. And I'm going to say OK. All right, so if we scroll down, you can see we have our third hard drive here. And notice that it says its maximum size is 100 megabytes, currently expanded to 100 megabytes. Now, most likely that's a fixed disk. But you can really inspect these disks. You can tell exactly what they are if you go over here to the virtual disk and you click on Inspect. You can either type in a path here, or you can do a drop down for known virtual disk. So here I'll put in the test fixed disk and say Inspect, and it tells me that this is a fixed size virtual hard disk. It tells me the full path, maximum size, and current size. I could also do Inspect, and I'll put in our dynamic disk, which is called Test 1. You can see here it says it's a dynamically expanding virtual hard disk. Current size is 24 megabytes, maximum size is 100 megabytes. So now let's go and start up this server, and let's configure the operating system to actually use our new fixed virtual disk. So I'm going to turn on the server. I'm going to do remote control on the server. It'll take just a second here to boot up and allow me to log in. As soon as I get the login prompt, I'm going to hold down the right control and I'm going to press the delete button. Not the backspace, but the delete button. Type in my administrator password, and we're in. So I'm going to close out some of these things that just seem to automatically pop up when you log in. I'm going to go to Start, Administrative Tools, and to Computer Management right here. And inside Computer Management, we have Disk Management. And immediately it recognizes that there's a new disk, and it says, do you want to initialize and convert this disk? I'm going to say Next. Sure, let's do it. It knows that this is disk 2. I'll say Next. It says select the disk to convert to a dynamic disk. Might as well. I'll say Next. It says, are you sure you want to initialize the disk and convert it? I'll say Finish. And if we scroll down, we see here disk 1, that's our old dynamically expanding virtual disk, 100 megabytes. Here's our disk 2, which is the fixed virtual disk, 99 megabytes. It says it's online already. If I right click over here, I can do a new volume. This is the new volume wizard. I'm going to go through here and create a simple volume on this disk. I'm going to assign the drive letter, how about O? And I'll call this fixed virtual disk. And we'll perform a quick format. Say Next. and finish. And in just a second, we'll have a formatted virtual disk. It said formatted, and now we have here a simple volume, a 100 megabyte disk. Fixed virtual disk is the volume name, and it's drive O. So now I can go down here, can open my computer, and here's drive O, and here's drive M. So drive M is our dynamic, drive O is our fixed. So we put something in M, we put this 12 megabyte file. I haven't put anything in O yet. If we go back here to our host computer, let's go look at these disks. So here's our test fixed disk, and you can see it already took up 100 megabyte, and I haven't even put anything in there yet. So it immediately allocated that disk space to the fixed virtual disk. On the other hand, here's the 100 megabyte test dynamically expanding disk, and it's only 24 megabytes. I put one file in there actually, and I formatted it, and it just took up 24 megabytes. Even though the operating system over here thinks that I have 100 megabytes on each of these disks. So this points out to you the difference between the fixed disk and the dynamically expanding virtual disk. Both of them, to the guest operating system, appear to be the same 100 megabyte disk. But back here on the host computer, they're drastically different. The fixed disk is 100 megabytes, whereas the dynamically expanding disk is only 24 megabytes. And the fixed disk doesn't even have any data in it. The dynamically expanding disk does. It has a 12 megabyte file on it. So that's the difference between the two. And this is just an example here with small files and small virtual disk. But if you, instead of making a 100 megabyte virtual disk, if you made a 100 gigabyte virtual disk, immediately your disk space is gone if you're using a fixed virtual disk. On the other hand, fixed virtual disks, of course, are better performing, and you know that they're never going to expand larger than what they are, and you can, immediately allocate that disk space to your virtual servers. You don't have to worry about having 5 virtual servers running that we're only taking up 25 megabytes, and then all of a sudden their disk expands to 125 megabytes, or 125 gigabytes, excuse me. So that's the benefit of using a fixed virtual disk, is its predetermined size helps you plan your disk space utilization better. It also locks you in though. So you really need to know ahead of time exactly how much disk space your operating system, your applications, and your data are going to take up on that virtual server. So with that, let me close this out, and let's go back to our slides. All right, so we just finished talking about fixed virtual disk, and now we can move on to linked virtual disk. So a linked virtual disk is unlike a dynamic and a fixed virtual disk. Linked virtual disks are pointers that point to a host's entire physical disk. Linked disks are not meant to share files or be used as real disks. Instead, linked disks are meant for the conversion of a physical machine to a virtual machine. Now, many times this is called a P to V conversion, or physical to virtual conversion. Now, when you link a disk to the host disk, the host can no longer access that disk. So what does that mean to you? Well, you can't create a linked virtual disk to the host's root drive or C drive, like C:\Windows. It would have to be another drive, maybe a data drive on that host that you could create a link to, and you could copy data off of the physical linked disk onto the virtual linked disk. So that's really what it's for, is to move data from a physical disk on a host to a virtual disk on a virtual machine, and it cannot be the root drive or the C drive most of the time. So let's take a look at this link and see how this works. So Microsoft TechNet entitles linked virtual disk under the section copying a physical disk to a virtual hard drive or virtual hard disk. So that's what linked virtual disks are used for. So it says here that you can create a copy of the physical hard disk for use as a virtual hard disk so that the virtual machine can use an exact duplicate of the contents of a physical hard disk. This process uses virtual disk management features. Let's go on down here where it talks about linked virtual disk. Now, create a linked virtual hard disk. You can use this procedure to create a linked hard disk, a .vhd file, linked to a physical disk that stores the contents you want to copy. When you complete the procedure, the VHD file will not contain a copy of the contents of the physical disk. It's simply a reference point. That's important to point out there. The linked virtual disk, the .vhd file, isn't the actual data, it's a reference point to the physical disk. Now, to copy the disk contents from the physical disk to the .vhd file, you must convert a linked virtual hard disk by completing the second procedure. So let's learn a little bit more about that. Now, when you create the linked virtual hard disk, you specify temporary name and location. Okay, that's fine. You convert the linked disk to a dynamically expanding virtual hard disk. You use this procedure to copy the contents from the physical disk to the virtual hard disk by performing a conversion. When you perform this procedure, you make the following selections. So basically, what you do is you create the linked virtual disk that points to a physical disk. So you have this VHD file out there, but it's empty. It's just a pointer to the physical disk. But then what you do is you do a conversion from a linked disk to a dynamically expanding virtual disk. And when that happens, virtual server copies everything on the physical computer's hard drive onto the virtual computer's VHD disk. So essentially, you're copying everything at that point when the conversion happens. So this is pretty cool if you're trying to convert from a physical computer or a physical machine to a virtual machine, a P2V conversion. So let's go in and let's just briefly show you how this works. I'm not going to demonstrate it, but I just want you to see basically how it works. So if I go into the Blue Crab Food server here, we're just going to go to the master status. So I would go to virtual disk here and I would create a linked virtual hard disk. And it asked me for the location. Say I just put it in that common area there. And I'm going to call it test-linked.vhd. So it's still a VHD file. And then what I would do is I would select my physical hard drive. And it's kind of hard to tell from here which hard drive is which. But for example, I have a USB drive that I know is 80 gigabytes. And I believe it's the last one I connected here recently. And I believe this is it. If I go over here to my computer, you can see I have the same 4 drives here, 2 74 gigs and 2 372 gigs. It's the same thing on the list over there, but they're actually in a little bit, different order over there because it started with a 74 and it ended with a 74. So you have to be careful to make sure you get the right disk. You definitely do not want to mount your operating system's, C drive or the root drive of your operating system. So what you would do is you would create this, and it says, let's see, let's verify that it was actually created. I'm going to go to My Computer, C drive, Documents and Settings, All Users, Shared Documents, Shared Virtual Machines, and here we have our test-linked.vhd. It's just a little 65 kilobit VHD file that we created as our test. So now what we would do is we would go to Inspect, and we would inspect this virtual disk, test linked, that's what it's called. I would inspect it, and it tells me that this is a linked virtual hard disk. And what I would do then is convert this. I would convert this to a dynamically expanding virtual hard disk. So I would type in the name right here, select the path, type in the name, and then type in new dynamic disk converted from linked.vhd. Then I would click convert. And then what it would do is it would copy all 80 gigabytes of the data that's on that that G drive that I have on my computer, that USB drive, it would copy all 80 gigabytes of data from the physical drive to the new dynamically expanding virtual hard disk with this name here. And voila, I have a new virtual hard disk that's been converted from a physical disk on the physical computer or the host computer. So it's a great way to do a physical to a virtual conversion. Um, if you're not doing a P2V conversion, it's probably not going to be that useful. And also, this could take quite a while. You know, I have 80 gigabytes of data, and that's why I'm not going to click the convert button right now because we could be sitting here for a while watching the conversion happen. So that's how linked virtual disks work. So with that, we'll go back to our master status. I'm going to close this out, and let's go back to our slides. So we just learned about linked virtual disk. And now let's talk about undo disks. So there's a couple different types of special disks. And these disks, sort of like linked disk, aren't used in the typical day-to-day virtual server administration. You know, dynamically expanding and fixed virtual disk are really the two most popular, the two most common types of disk on a virtual server. When you get into linked disk, undo disk, and differencing disk, uh, the two latter ones, which we're about to talk about, these are sort of special cases. These give you flexibility to do something special. So linked disk, undo disk, and differencing disk, they're all special disks. So neither undo disk nor differencing disk are used as primary disks. Instead, these give you flexibility, just like I just pointed out. Now, undo disks are used to store all changes to one disk on a separate disk. This allows you to roll back changes to another virtual disk. So what that means to you is I take the primary disk of my computer. I create an undo disk for it. What that does is it puts the primary disk in read-only mode. And then you have this undo disk where all the changes are being written. Once you get to a certain point in whatever it is you're doing, you can choose to get rid of the undo disk and go back to the original. So you're rolling back that virtual hard drive back to where it was before. Or you could choose to apply the changes that are in the undo disk back to the original disk. In that sense, you're combining the two, you're merging the two. So that's what undo disks are designed to do. Now, undo disks have the file type extension .vud, and they're stored in the same directory as your .vmc file. Now, the important thing to know about undo disk is that they apply to a single virtual machine, and they apply to all virtual hard drives on that virtual machine. So if I enable undo disk on a virtual machine that has 3 virtual hard drives, undo disk will be created for all those virtual hard drives, and all those virtual hard drives will be put in read-only mode. The changes will be sent to the undo disk, and then I'll have the choice to one day apply those changes back or get rid of the changes and go back to the original disk that have been marked read-only in this time period. So undo disk apply to an entire virtual machine and all the virtual hard drives on that virtual machine. Now, undo disks are very useful for testing applications or configuration changes and then rolling back the virtual machine to its original state. Now, when you enable undo disk, you'll have more options in your virtual machine's save state options. You'll have the option to keep the undo disk, discard the undo disk, or commit undo changes. Now, two things to know about undo disk is that one, they can hurt performance. This is because your original disk is put in read-only mode and all the changes are written to this undo disk. Also, they can become very large over time. So if you start doing a bunch of application changes or installations or moving data back and forth, undo disk can just grow and grow and grow. So it's something that you want to keep an eye on. So with that, let's go and let's create some undo disk for our Microsoft virtual server. I'm going to go over here, and the first thing I need to do is I'm going to turn off this virtual server. Not something, again, you should do on a production server. This is just a test server, though. All right, so now to create our undo disk, I'm going to go in here and I'm going to first edit the configuration for this virtual server. I'm going to scroll down here and I'm going to go into the hard disk section. And if you look right here, there's a checkbox. It says Enable Undo Disk. And what it does basically is it creates an undo disk for all your virtual hard drives on this computer. And it puts these virtual hard drives, they're listed here in read-only mode, and all writes or all changes are written to these undo disks. So by checking that checkbox, that's really all I have to do. Now if I go over here and I click OK, the change has been made. And if you notice here in the hard disk section, it says that undo disks are enabled. So you can see that it's enabled right there. Now if I go in and I start this virtual server, if I turn it on, let's minimize everything, and I'm going to go to my computer, going to go to the C drive, documents and settings, all users, shared documents, shared virtual machines, and then in here into the subdirectory or the folder for the Blue Crab Food Win Server 2. And right here in the same folder where the VMC file is, the virtual machine configuration file, you see actually three different virtual undo disks. See the .vuds right here, these three different files. This one is growing. You can see that it's 3128. Just a second ago it was 2000 something. These two are also growing. There you go, that one just grew. So you can see changes in the virtual undo disk. And what's happening is the three original disks are put in read-only mode, and these three undo disks are storing all the changes to those original virtual hard drives. So as the server boots over here, changes are made to the disk drives, and those changes are written right here on the undo disk. So if I go back to the server, and I'm going to do remote control, oh, I think I mistyped that. There we go. I can log in here. Yes, we had an unplanned shutdown. And as things happen, you see this undo disk here, the primary, has already grown to 47 megabytes. So if I go down here to the master status, actually you can see it already here, the different options that have come for this new virtual machine. If I go to master status, I hold my mouse over it here, you can see different options like save state and keep undo disk, save state and commit undo disk, so it would write all the changes on the undo disk and apply them to the originals. I can shut down the guest OS and keep the undo disk, or shut down the guest OS and commit the undo disk. Same thing for turn off virtual machine. I can keep them or I can commit them. And then the different option here on turn off is I can discard the undo disk. So whatever changes I made, I can just get rid of them like I never even made those changes. So there's a lot of different options that undo disks give you, and it allows you to roll back to whatever configuration you had before. So to me, the ideal situation is you create undo disk, you apply a new patch, you see how it works, and then when you're done, you get rid of the undo disk and you go back to how you were. Just one way of testing the patch. Maybe you do this over and over again to test some Microsoft patch you're about to roll out, or another application you're about to roll out some changes to. So let's make some changes to our virtual server. Let's just create a couple icons on the desktop. I'll call that test folder. I'll go over here. I'll create a new WordPad document called this document has been changed. Yes, go ahead and change the file name extension. So there's just a couple things there I put on my desktop. And now what I'm going to do is I'm going to scroll down here and I'm going to turn off the virtual machine and discard undo disk. And essentially what that'll do is all the changes that have happened to this virtual machine, including my two changes I made right here, will just magically be gone. So let's go ahead and do that. pausing for just a second. Let's see if it really happens. There we go. Are you sure you want to turn off this virtual machine? Unsaved data in the guest operating system will be lost. And actually, everything will be lost for real because of the undo disk. So I'll say OK. It turned off that virtual machine. It still says that undo disks are enabled. Let's see, it just updated. Okay, it still says they're enabled. Let's go into hard disk. And even though they're still enabled, even if we reboot this server, those changes that I made, because I chose to discard the changes to the undo disk, those documents and folders that we created on the desktop there, those will be gone. So I'm just starting up this virtual machine here because I want to show you exactly how this works. So in just a second, the machine will be started back up. I'm going to do remote control. And we'll log in as administrator, and you'll see that the document and the folder that I put on the desktop will be gone. The other thing we could have looked at is right back here, if you notice, in this directory, notice how small the virtual undo disk had become. If you'll remember, this first one here was already 40-something megabytes. So when I told it to discard the changes to the virtual undo disk, it wiped those out. Those were gone. And now that undo disks are still enabled, when it's rebooting, it's creating these fresh again. So let's log in. Whoops. There we go. Okay, we had an unplanned shutdown. And voila, the changes that I made are no longer there, and that's because they were stored in those undo disks. And when I said discard those changes, of course, those icons were gone. Now, those icons are just a small representation of what your changes could be. You know, your changes could be upgrading here from Microsoft Windows 2003 Server to Windows Longhorn Server, or applying Windows Service Pack 2 or Service Pack 3, or upgrading from Windows XP to Windows Vista. You know, these could be major changes that you're making to this virtual server, and with undo, you can just get rid of them and instantly go back to where you were before. So it's a very powerful feature. On the other hand, if the upgrade was successful, you could choose to merge those changes back into the original, which is an option down here. Commit the undo disk. So it commits those changes back into the original disk. So whatever upgrade you did, you can keep it. You don't have to discard it if you don't want to. So undo disks are a very important and a powerful feature, especially when it comes to testing. All right. All right, let's scroll down on our slides here and let's talk about differencing disks. Now, differencing disks are very similar to undo disks, but they're created for a single virtual hard drive. So undo disks, on the other hand, are created for an entire virtual server and all associated virtual hard drives. So differencing disks just relate back to a single virtual hard drive. Differencing disks are also stored in a second virtual hard drive, not a VUD or the virtual differencing disk, or the virtual undo disk, I'm sorry. Let me say that again. Differencing disks are stored in a second virtual hard drives, not a VUD or the virtual undo disk. So that's another difference between differencing disk and undo disk, is differencing disks have their own virtual hard drive that contains all the writes or all the changes to the original virtual hard drive that they're creating differences from. So differencing disks only contain binary level changes to the virtual hard drive, thus they're very small. We'll talk about merging and chaining of differencing disks a little bit later, but for now let's take a look at differencing disks. So if I go down here to our virtual server web administration page, and I go over to virtual disk and create, I can go here and I can create a virtual differencing hard disk. So if I click on that and I go over here, it tells us that a differencing virtual hard disk is a virtual hard disk associated with another virtual hard disk in a parent-child relationship. the differencing disk is the child and the associated virtual hard disk is the parent. So these differencing disks contain the differences from the parent that have been made since they were created. So first right here it says, let's make sure we follow the directions. They're very specific here. Specify the location where you want to create a differencing virtual hard disk. You can select a location from a list. So this is where the new virtual differencing disk will be. So I'm just going to call this test diff.vhd. So it's a VHD file, just like all the other virtual hard drives we've created. So I called it test-diff. Okay, down here it says specify the location of the virtual hard disk that will be the parent. So this is the original down here, and this is going to be the differencing disk up here. So the known virtual hard drives, it's kind of hard to read these paths because they're so long. So this is our original Blue Crab Food WinServer 2 virtual hard drive. That's its boot drive. So this differencing disk is going to contain all the differences that happen to this original hard drive since the differencing disk was created. So now to create the differencing disk, I just click Create right here. One thing we might want to take into account is this server running? We don't want to create that differencing disk if the server's running. Let's go back to master status. Sure enough, it is running. Let's go ahead and let's shut it down and let's discard undo disk. Okay, let's go into edit configuration and let's remove our undo disk before we add differencing disk, just to prevent any sort of confusion. Okay, so I'm going to disable the undo disk. All right, and undo disk are disabled. I'm going to go here and create a virtual disk. It's going to be a differencing virtual disk. I'm going to put it in this root directory. I'm going to call it test diff.vhd. I'm going to select our known virtual disk. Make sure we have the right one. WinServer2.vhd, sure enough, and I'm going to say create. Okay, let's refresh. And it tells us the virtual hard disk testdiff.vhd was created. So we created our differencing disk. Let's go take a look at it in Windows Explorer. If I go in here to C:, Documents and Settings, All Users, Shared Documents, Shared Virtual Machines, you can see right here, here's our testdiff.vhd. So this is a virtual hard drive that contains all the changes that happen on the hard drive, the parent hard drive that we selected in this folder here. So this is the parent hard drive, it's 1.5 gigs. And if I go back here, this is the child hard drive. This is the differencing disk for the child hard drive of that parent. So if I were to start the virtual server and make some changes, of course, you're going to have changes on the root drive. When those changes occur, this differencing disk is going to record the binary differences between that parent hard drive and the time that the differencing disk was created. So all those binary changes will be stored in this differencing disk file. So let's go back to our slides, and we talked about differencing disk, and we learned how differencing disks are created for just a single virtual hard drive, whereas undo disks are created for an entire virtual server and all virtual hard drives associated with that server. So now let's move on and let's talk about converting virtual disk. So a common question is, can you convert from a dynamic expanding virtual disk to a fixed virtual disk? And you can convert from a dynamic to a fixed disk. Now both disks must exist already, and then what you do is you use the inspect virtual disk option, and the primary reason to do this is for performance and predictability, of course, because that's what a fixed disk gives you. And then you can convert from a fixed disk to a dynamic expanding disk. So only dynamic expanding virtual disks can be compacted, which means if they have more space allocated to them than they really need, they can be shrunk down. So to compact a fixed disk, the only way to do it is to convert it first to a dynamic. Now, there may be other reasons that you want to convert from a fixed disk to a dynamic for other reasons. But many people do it just to shrink their fixed disk that has too much disk space allocated to it down to a dynamic. So let's go into the web interface and let's see how to do some of these conversions. So to do any sort of conversions, I go to Inspect Disk, Inspect Virtual Disk. Here I put in the known virtual disk. So say I put in my fixed disk and I say Inspect. It knows that it's a fixed disk and it tells me I can convert it here. And it says specify the location. Converting a virtual hard disk can use a large percentage of processor. It's recommended not to do this on a production computer. So here I can convert it to a dynamically expanding virtual hard disk. So it knows it's fixed and it tells me I can convert it to dynamic. So here it asks me where I want to put it. Well, I can say test fixed convert .vhd. It's not a very big hard drive, so we'll just see how long it takes. Here it shows me the progress bar. And it's done. It tells me right here it was completed. So let's go take a look. I'm going to refresh this. So here I had my test fixed disk with only 12 megabytes of data in it. And here you can see I converted it right here to this test fixed convert.vhd. This is a dynamic expanding virtual disk. So I converted from the fixed size of 100 megabytes with only 12 megs in there down to 12 megabytes with a dynamic expanding virtual disk. So that's one way of getting back disk space quick and easy. If you had allocated fixed virtual disk, you needed some more disk space, you can quickly convert them, or relatively quickly, depending on their size, down to a dynamic virtual disk and save some disk space. So that's how you compact from fixed disk to dynamic disk. So if I go back here, now let's look at how to convert from a dynamic expanding to a fixed disk. So if I go back here to our client and I go to Inspect and I open, let's see, Test 1. This was our dynamic expanding disk. If I inspect this, it shows me it's a dynamic expanding. Now I have a couple different options here. First, I can convert it. I can convert it to a fixed hard disk. The other thing I can do is I can compact it. So compacting is a way to shrink a dynamic disk down and not use as much disk space as is already allocated. And that disk space gets allocated when files are created and then they're deleted, but the disk doesn't automatically shrink back down. So I can convert it to a fixed or I can compact it. That's what I can do with my dynamic. All right, so we talked about converting disk. Now let's talk about compacting. And we just touched on that, really. Compacting can take a long time and a lot of resources, so keep this in mind. It all depends on the size of the disk and how much data is in there. To compact a disk, you can go into Inspect Virtual Disk and keep in mind that it has to be a dynamic disk. So we went back here. We already opened our dynamic expanding virtual disk. I can go in here to compact. Keep in mind it was using 24 megabytes. I'm going to compact it. Let's see if we can get some space back. All right, it tells me here that it was successfully compacted. Let's go inspect again. Let's open up our test1.vhd. And it's still using 24 megabytes. So that's the best we could do with the data that's inside that virtual dynamic expanding disk. So that's how you compact virtual disk. All right, so now let's move on to merging. Now you can merge undo disk and differencing disk. This takes the changes and merges them back into the original. Now when doing this with differencing disk, make sure you have plenty of time and disk space. It could take a long time. Now to merge undo disk, you'll be given the option when the virtual machine is shutting down. And we looked at those options. You know, when we had undo disk enabled, It said, do you want to shut down and merge the undo disk back into the parent? And you could say, yes, you could take that option, and it would take all those changes and put them back into the original. Now, to merge differencing disks, you have to go in and make the selection with the virtual machine shut down. So let's go in here, let's see how we merge. So what I do to merge is I inspect, and I actually inspect the differencing disk. So our differencing disk was called test-diff.vhd. If I inspect that, it gives me the option right here to merge. Now it knows that this is a differencing disk, and that's how it knows that I can have the option to merge it back to the parent. So if I choose that, it tells me I can either merge it back to the parent virtual hard disk, or I can merge it to a new virtual hard disk. I can even choose whether I want it to be a fixed or a dynamic expanding. So that's merge. And we already saw how the undo disk work. When you go to shut down or pause the virtual machine, you can, at that point, you can choose to merge those undo disk changes back into the parent. Now let's talk about chaining. Now you can have chains of differencing disks. This is a parent-child-grandchild relationship. All the children are based on the parent. So if the parent's lost, all the children are lost. Now this is for advanced users, and it can be very fragile, and I recommend that you use it with caution. But if it's used in the right scenario with somebody who really has some good experience doing this, it can be very helpful. So picture you having a single disk on your virtual server. You create a differencing disk, and then you create a differencing disk off of that differencing disk. So that's the kind of parent-child-grandchild relationship that I'm talking about. And then you can go back and you can individually merge one or all of these differencing disks back into the parent, or the grandchild could be merged into the child, or however you want to do it. It can be a long tree of different disks that can be merged in different ways. So keep that in mind. Not something for a beginner or an intermediate user. In fact, in my time using virtual server, I've never found a real application for it, but I've read about people who have used it and have had great success with it. And with that, we've reached the conclusion of video number 5 covering virtual disk in Microsoft Virtual Server. So in this video, we learned about the different disk file types, and we answered some common virtual disk questions. We learned what a VHD is, what a VSV is, what a VUD is, and all the different types of virtual disk extensions. We learned about removable media and disk images using those ISO files. We learned the difference between dynamic expanding and fixed virtual disk. Then we learned about some special disks called linked disks, which are used for physical to virtual conversion. We learned about undo disk and differencing disk. Undo disk apply to the entire virtual server and all the virtual hard drives associated. Differencing disk, they just apply to a single virtual hard drive. And with undo disk and differencing disk, you can choose to merge the changes that are written to these special files back at any point if you choose to do that, or you can choose to discard them. So undo disk and differencing disk are great for performing tests of new applications, or tests of service patches, and whatever kind of testing really you need to do on a virtual machine, and then be able to roll back to whatever it was you had before. Those are very powerful for doing that. We learned how to convert virtual disks. We saw how to convert from fixed disks to dynamic expanding, and then from dynamic expanding back to fixed disk. We also learned how to compact dynamic expanding. And by the way, dynamic expanding are the only types of virtual disks that can be compacted. We learned how to merge virtual disks. Merging virtual disk is done with either undo disk or differencing disk. Then we learned how to chain virtual disk, well, at least the basics of chaining virtual disk, I should say. Chaining virtual disk is used with differencing disks, where you create a parent-child-grandchild relationship, and you chain all these changes together in different disks. And that brings us to the end of video number 5, Virtual Disk in Microsoft Virtual Server. Thank you very much.